Hi there. So I believe this is my final presentation for the course. No, this will end not just our lesson on bivariate analysis, the final chapter of SOCSI 101, but the entire course as well. No, we will be introducing to you um, an extension of correlation. Now, if you want to use correlation in a uh, much more complex way, no, to give or provide you with more information on the relationship between two variables, you need to do regression analysis. Now, just like correlation, no, there are multiple forms of regression analysis. And for the class, no, for this undergraduate statistics course, we will be learning about simple linear regression. No? In the future, no, if you decide to pursue advanced studies in, especially in psychology or in mathematics or in statistics, you will encounter other versions or forms of regression analysis, much more complex, much more um, complicated, and will allow you to deal with not just two variables or two interval level data, two sets of interval level data, but other types and classifications of variables. And will provide you with more in-depth analysis of the data. But for now, no, for you to get there, it's important that you first learn the basics of regression analysis. All right. So this is the outline for this final presentation. No, so we will look at the difference between correlation and regression and move forward with the elementary um, parts of a regression, a simple linear regression. All right. As you can see, no, there are some familiar terms here, no, like correlation and coefficient of determination. So this is what I'm saying now. This lesson on regression analysis is an extension of what we know so far about correlation. And it's basically, it will basically show you how you can use correlation in much more meaningful ways. No, aside from identifying if a relationship exists, the direction and the strength or consistency of a relationship. No, so let's look at that precisely here. So what is the difference between correlation and regression? Let's start with the objective of each. No, for correlation, as you've already known, we're after the degree and the magnitude of the relationship between two variables, no, that are presumed to are that are presumed to have a relationship to one another. No, we want to know if how one variable tends to change when the other variable is manipulated or is modified. No, so that's the simple objective of a correlational analysis. On the one hand, regression analysis is not only interested in the relationship between variables, no, regression analysis also does that by, using correlation, but regression as as an important part of statistics or inferential statistics aims to make predictions, no? Specifically how to predict if an individual standing on one variable is a certain value. No, how can we predict that individual standing on another variable? So if you remember, correlation is identifying or scoring individuals on variable X and variable Y, right? The predictor and the criterion and the predictor. Ganun din dito sa regression analysis, except that the regression would help you with predicting scores on Y when you have knowledge of X. No? When X is given, regression will help you predict what is the likely score of an individual or a subject on the variable Y. All right. So yeah. Speaking of variables, the role of variables for correlation and regression analysis are similar but different. In correlation, the variables assume one role, and that is one will be correlated with another and vice versa. So remember our discussion on interpreting correlations. No? Correlation will not tell you about causation. It will simply show you if the two variables are related and the degree of that relationship. No? So in multiple correlations, we also do that. No? If one variable is related to an array of other factors, other variables, other correlates. Now in regression, you need to be more precise, and you need to identify the role of the two variables that you are correlating or you're analyzing. So one variable must assume the role of an independent variable or the predictor. No? Usually this is your X that will predict or estimate the outcomes on another variable or the scores on another variable known as the DV or the dependent variable, which is your criterion. So thus in regression at the onset, the researcher must specify which is the predictor and which is the criterion. No? And they do that in stating their hypothesis. No? So there. Regression analysis helps explain why variables vary by identifying characteristics or factors that account for the variation. No, this statement is more applicable to multiple regression, no, not simple linear regression, because in simple linear regression, it's just like correlation, wherein you're just dealing with two variables. In multiple regression, you can have as much as 10, 20 independent variables or predictors, and you can correlate that with usually one DV or one criterion, but you can also even add more DVs. So it's much more complex than a simple correlation and a simple linear regression. So yeah, that's what regression can help by identifying what factors and characteristics significantly account for the differences or variations in scores or outcomes on the criterion or the dependent variable. It allows us to quantify precisely the relative importance of any proposed factor or variable. So let's say in self-esteem, what factors correlate with self-esteem? Is it sex assigned at birth, birth order, what else? Culture, so ethnicity, age, no? So yan, pwede mo sabay-sabay na gamitin as your predictors of self-esteem. No, but yun nga, as I've said, in simple linear regression, usually we just stick with just one IV and one DV. So let's say you're interested in intelligence and self-esteem. So your intelligence is your predictor and self-esteem. So meron ba siyang relationship? Can intelligence score predict a person's self-esteem? So something to that effect. Now, the coefficient, I used this a lot in the previous presentation on correlation. We compute for a correlation coefficient. That's Pearson's R, Spearman's rho, phi coefficient, the gamma, and all the others that I did not include in the presentation, like tau b, tau c, point by serial, no? Kramer's V, contingent coefficient. So yeah, it's quite simple and straightforward. You need to find this value, and you can already describe the existence, no? Because of the numerical value, the direction because of the positive or negative sign of the numerical value of your coefficient, and the strength and consistency, no? Depending on gaano kalaki or kaliit yung coefficient that you obtain. In regression, on the other hand, you are computing many things, more things. Now you have a regression constant, you have a regression coefficient. Now, and these are used to construct a prediction model, because in regression, you will end up with the regression equation, which is, once again, very familiar to you if you recall your high school and college algebra, because it's that equation that you encounter in those subjects or courses. But now that equation will be used to estimate and predict outcomes on the dependent variable or the criterion variable. Okay? And aside from a constant and a coefficient, a slope and an intercept, so to make it even more obvious to you guys, we also end up with an error term in computing for a regression equation or a regression model, this prediction model. So yeah, it just became a little more complicated than computing for a correlation coefficient. No. And in regression analysis, you also still compute for a correlation coefficient aside from these regression terms. All right. So, making predictions in the social sciences. So, for us to move forward to regression analysis, your correlation first should exist, and the existence should be significant. No, the two variables you're trying to study must be significantly correlated first before we move on to regression analysis, because that tells us that your independent variable can actually be used to make predictions or estimates on your dependent variable or your criterion. Now here, our goal is to arrive at a linear regression equation. No, it's a mathematical expression of the regression line that will help us make those estimates of your DV. Now, based on subjects or individual scores on the IV. And as I said, the linear regression equation is somewhat a familiar equation to you guys. It's y is equal to a plus bx plus e. In your earlier maths, in your educational career, in your academic career, this is y is equal to mx plus b, right? That's why I mentioned the slope, the y-intercept. So we are using that. We are using the logic behind that to come up with a linear regression equation, which we will use to make predictions about your DV or your criterion. All right, so what are the elements of this equation? For statistics used in social research, y pertains to the dependent variable or the criterion, no? The variable you're trying to predict. No, it is the variable of interest we are trying to explain or predict. So I've corrected. X, on the other hand, here in this equation in Bx, is the independent variable of the predictor or the predictor. Sorry, I think nag-change ng the mga font because I transferred it. Anyway, it's an independent variable or the predictor. The value of the known variable or the DV or the IV that you will use to predict y. Okay? B, on the other hand, is the B coefficient or the regression coefficient. In non-statistical terms, it's the slope or the gradient of the line. And the meaning of that slope is very important because it is the amount of change that we expect on average in the dependent variable y for every 1 unit change, for every 1 unit increase, or for every 1 unit decrease in the independent variable x. Okay, so I hope you remember that because that's basically the interpretation of B. A, on the other hand, is the y-intercept or the regression constant. No? So in earlier maths, that was supposed to be B, but now we're calling it A. It is the point where the regression line crosses or intercepts the y-axis. For interpretation, it simply means in regression analysis, A is the value of y when x is 0. No? So when you plug in the values and x is actually 0, this is your baseline amount of y. No? If we know x to be 0, when the independent variable x is 0, the dependent variable y is equal to this value. No? So without x, this is the value of y, the baseline amount. E, as I've said, is the error term or the disturbance term. It's the residual value that is unpredictable and unique to any individual. No, it is the amount that cannot be explained by your slope, that cannot be explained by your slope or by your y-intercept. No, it represents any departures from that which would be expected on the basis of x. No, so usually when using the regression equation, we sort of remove the error term. No, it's just there to remind us that there are individual differences that explains why our predictions sometimes are why our predictions of y are not always equal to the actual values of y. No? So dun pumapasok yung nuances of individuals. No? Their experiences, their personality, so and their experiences, their personality. No? So in social sciences, we like recognizing that our models for prediction are not perfect because of this human factor. No, and I think I also mentioned that when we were studying analysis of variance, right? And all the other techniques, statistical tools and techniques that we encountered in the class. Na it's very difficult to come up with something that's very precise, no, a model that can absolutely predict outcomes because there's a human factor involved in everything that we deal with in the social sciences. So, such that no, there is some sort of humility there when we say that when we use this prediction model, this regression model, the values that we will get when we use this equation will be point estimates. They will be best guesses that we can come up with of the actual or true value of y. No, so if I want to predict self-esteem using intelligence, when I find the perfect when I find the most suitable regression model for it, yung mga predictions ko will not be entirely accurate. It won't be 100% right all the time, but because of science, no, because of the logic of regression, I can still have some confidence that the value that I've predicted is the best estimate that I can come up with and I can show to people. So there. So I'm talking about the regression model and I keep talking about this equation, right? Now, why do we need this equation? Because the equation will give us the regression line. And what is the regression line? First, we need to understand that in regression analysis, the primary goal is placing or fitting a line through the scatter of points. No? If we come up with a very accurate regression line, no, wherein the value of your y-intercept or a would be the location where the line crosses the y-axis and the slope, or your b, which would correspond to the rise or fall of the line for every unit increase in x. Now, so what does this mean? Pretty much the goal of regression analysis is to come up with the regression line, which is the straight line which the points of your data lie close to. It falls closest to all the points in your scatter plot. And we need this because it pertains to the line of best fit. Now, it is the line that will help us make the most accurate predictions of y, no accurate predictions of your dependent variable. It is a line that best represents or best approximates all the points or all of the bivariate or correlational data collected. No, with that simple equation that we will solve, it will give us a line, and that line will give us the average trend of all the dots in the scatter plot. And kaya siya line of best fit kasi it will give us it's the most preferred line over all other possible lines that we can use to predict the dependent variable. So let me sort of clarify that now. Since the regression line is the best estimate of the data that we collected, using this line will lead us to less errors. No, it will make predictions that will give us the least amount of prediction errors. And the lesser prediction errors, the more accurate the estimates of individual scores are on your dependent variable or your criteria. No? So that is why we do regression analysis. But I would liken it to the earlier goals of the descriptives, coming up with one value that best summarizes, best sums up, best generalizes the aggregate data. No? Ganon din yung regression model. We need to find a model / an equation / a line that will give us the best, most accurate predictions. Not perfect predictions, but near perfect. Near perfect. No, most accurate predictions of the dependent variable. No, and when I say most accurate, ibig sabihin less prediction errors. No, so that's not saying that we won't make mistakes. No, when we use this model, when we use this line, but at least we minimize the errors to our guesses, to our estimates, to our predictions. Okay? So some notes on the regression line. First, so ito. Since the regression line provides the best but not the perfect fit of the data, it is not entirely accurate. No, but it's the best shot that we've got. Now, if you follow the procedures of regression analysis well, ito na yung pinaka-okay na gamitin compared to other alternatives out there because it gives us the average trend, but not the exact trend of all the dots. No, otherwise, we won't be doing regression analysis if we can really give an exact trend of the dots of the data. No, so for this, it's just the average trend. So because of this, there are certain limitations to the regression line. No, sometimes it can underestimate or underpredict the performance of some people, those whose scores fall above it, and overestimate or overpredict the performance of others, those whose scores fall below it. No, so I would liken this to entering university. No, at the start of your college journey or college experience, no, with certain tests, no, that you take, your performance for university will be predicted, no, and you'll be given values for that, no. Like for instance, I would say this is not entirely about regression, pero like let's use the UP grade for instance, no. It'll give you scores on certain variables, and it's an indicator of your success or your performance in throughout college. No, and sometimes the predictions that those scores help make won't be entirely accurate. No? Others will prove themselves and have grades that are better than their UP expected grades. Now, others naman will underperform and they will end up with lower grades compared to what were predicted for them. So ganito rin sa regression line, it's not a perfect predictor of the dependent variable. Sometimes it will err, sometimes it will be accurate, sometimes naman it will underestimate or overestimate. No? That's why predictions made for subjects with extreme scores on the predictors are less accurate than predictions for subjects with scores close to the means of the predictors. So here's what we need to remember when we're using regression analysis not to make predictions. One, we need to accept and expect that some amount of error between actual and predicted Y values will be present. No? Yun yung kaninang error term, the prediction errors that I was talking about. So there's a human factor there. No, we can't isolate X and Y perfectly. Therefore, the regression model that we will come up with will not give us accurate predictions all the time. Second, we will observe that some people will perform better than expected, while others will perform worse than expected. So yeah, that's what I was saying. And lastly, we will be better at predicting the performance of average subjects or those with scores closer to the mean than above average or below average subjects or those with scores farther away from the mean. So yeah, people who will get extreme scores on Y, we expect that the regression line will overestimate or underestimate their scores or performance. No? And it'll just come as a surprise na they don't fit the trend, essentially. No? So if you're an individual who tends to be more average, then the regression line, the regression model will be able to accommodate you, will able to more correctly predict how what you will score on the criterion. No? So solving for the elements of the equation is quite simple, no? But as you can see, you will once again need an expanded data table to fill out these elements. No? So for A, you need the sample mean, the mean for the Y scores, and the mean for the X scores. I need to get B. B, on the other hand, can be obtained by getting this, no? The sum of xy, the total n in your sample, the summation of x and the summation of y, and the summation of x squared. So I was mentioning errors of prediction. So these are residuals or error terms, which pertains to the amount of error we expect between the actual and predicted y values, which you can compute by getting the difference between the actual y scores and the predicted or computed y values. No? So yeah, I will include this in the expanded data table as well, because you need to know how accurately the regression model predicts scores on y. And obviously, no, the larger the error of prediction is, that means the regression model faltered, no? Pero the smaller the error prediction is for a score for an individual, that means the individual fits perfectly with the trend that the regression model is trying to depict. Then we have the standard error of estimate. No? So I am not going to ask you to solve for this in the remaining requirements, no, for the course, no, but I just wanted to add this to you. No, it somewhat has the similar logic behind it with the previous lessons, no, on standard errors, no. The standard error of estimate for the regression model is a standard deviation of the prediction errors found for the regression sample and measures the accuracy of predictions made with the regression line. Now, kasi earlier, the prediction error here, the formula here is used for individual scores. Now, we want to, once again, come up with a single value to quantify and express how accurately the regression model predicts the criterion, right? And the standard error of estimate will do that for you. No, so you get the summation of all the prediction errors, the sum of all the prediction errors, and divide it by your degrees of freedom and square it. So that basically is the standard error of estimate. And you can use this to come up with confidence intervals for all your predicted y values, or for your values of y based on your predicted y values. And instead of confidence interval, we call them prediction intervals in regression analysis. No? So yan, kaya meron ding sariling formula for CI. No? But once again, I will no longer include this in the problem set. No? And yan. So we move forward to the last thing that you need to know about simple linear regression, which is the coefficient of determination and the coefficient of non-determination. So you've encountered R squared, that is the coefficient of determination, or simply the squared correlation, which quantifies to us the variance in the dataset that is explained or accounted for by the regression line. No? It is the proportion of variance in y determined or explained by x. And since it came from R, your correlation, it also ranges from 0 to 1. And it will always be positive because once you square a correlation, whether it be negative or positive, it will end up being positive. Now, coefficient of non-determination is k squared, or the coefficient of alienation. Ito naman, it's the percentage of variance in the dataset that is not accounted or explained by the regression line. No, it is the proportion of variance in y that is not explained by x. So, yeah, this is the total percentage that your independent variable x has not affected or has not explained well. So there. So that's your basics for regression analysis, basically an introduction to this topic. And to make you appreciate it more, now we will work on a sample problem on simple linear regression. So let me read to you the problem. So a teacher observed that students who are good in expressing their ideas using words in a clear manner tend to also do well with tasks involving numbers. He wondered, therefore, if students' verbal ability, the first idea here, no communication of your ideas, no written or oral communication, could somehow be related to their quantitative ability, no? Your numerical literacy, no? Your facility in solving math problems, number problems. To find out, the teacher randomly sampled 10 students and measured their verbal ability with a vocabulary and verbal reasoning test, and their quantitative ability with a numerical problem solving exam. The data gathered will be presented later. Now we need to test this at 0.05 and plot the data in a scatter diagram and display the regression line. Now, as an additional thing, a transfer student named Remy also took the vocabulary and verbal reasoning test, and he scored 600 in that test. But he has not yet taken the numerical problem solving exam. Therefore, he has no score on quantitative ability, only verbal ability. Now, with a verbal ability score of 600, no, what is his likely score in quantitative ability? All right, so let's go to the sample problem and try to answer that. So here is the sample problem. I hope you see it on screen. So now we have the table containing the data. We have your X variable, which is verbal ability, and your criterion, which is your quantitative ability, or Y. No, as you can see, the values are in the hundreds. So this might be a little challenging to compute. No? So as I've suggested in previous lessons, you can use your calculator. You can also use your Excel to help you verify your answers if they are correct. No, but for the problem set, I will need to see these elements. No, the simple linear regression expanded table, the computations table, and a diagram, and the elements table. All right. So let's see. So we have scores on X and scores on Y. So if you notice for the 3/4 of this expanded data table for regression, this is your correlation, right? This is the expanded data table for correlation. So we need to do what we did in our correlation sample problem. Now find the product of X and Y, square X, square Y, and get the sum of your scores on x, sum of your scores on y, sum of the product of x and y, and the sum of x squared and sum of y squared. No? Notice here that aside from our original 2, 4, 6, 8, 9, is it 9? 10. 1, 2, 3, 4, 5, 6, 7, 8, 10 students that was part of the sample. We have an additional student, Remy, who has taken the verbal exam but has not yet taken the math exam. No? So we're trying to predict his score on quantitative ability using only our knowledge of his score on verbal ability. No? So let's fill out this table. So for verbal ability, we need to get first the sum. So the sum of this is 5,845. No? And for y, it is this 6199. And why is it important? Because that's part of the numerator for your b. And sum of x and sum of y. And of course, it's also used for Pearson's R here. Now let's find the mean. The mean for your x scores, you just need to sum up the scores, we got it already, and divide it by the total number of n for x. So that's 10. So 5,845 divided by 10 is 584.5. And for quantitative ability y, sum all of this and divide it by 10, you will get 6199. All right. Now let's go to the third column, xy. So multiply this with this. And you should get 289,976. Do the same for the rest and sum. So I'm just fast forwarding the process, but I did compute this one by one using my calculator and later on verified my answer using Excel. So the sum of xy is 700, no, this should be larger. 3,702,220. Now square x. So 536 squared will yield 87,000, nope, 287,296. Do the same for the rest and get their sum. So I hope you're still following. So sum is around 3.5 million. Then y squared, square this, and then this, and then add all the y squareds. So for this one, it's 292,681. So do the same for the rest of the students and sum the y squared. There. Now, if we can't answer the remaining columns, we first need to compute for the elements of the regression equation. So let's start with B. We already have this with this, and we also have the summation of x, summation of y. Itong dalawa. Then x squared, we also got that. Ito siya. Right? So it should be straightforward. So let's check. There are 10 students. This is the sum of x, y. This is the sum of x. This is the sum of y. This is the sum of x squared y. And this is the sum of x. So let's just answer it completely. Yan. Don't forget the signs. All are subtraction. So you'll end up with the B coefficient of 0.772. All right. Now, how do we interpret this? Go back to the meaning of your slope or your B coefficient, and it will look something like this. For every 1 unit or 1 point increase in verbal ability, students' quantitative ability increases by 0.772 points. Bakit increase? Because the sign of your B coefficient is positive. It's 0.772. If we got a negative score here or value here, then we say it decreases by 0.772 points. But since it's positive, it increases by 0.772 points. Okay? So now we have B. So ilalagay na lang natin siya to find A. And we also have the values for your mean of x and mean of y. So it should be very straightforward. Yeah. So you will get around 168.651 as your regression constant. No? And what again is A or your regression constant? It is, ito yung interpretation niya. It is the value of y when x is 0. No, it's your baseline amount. So here we can say the baseline amount or the baseline score for quantitative ability, if we do not know verbal ability, is 168.651. No? So the value of students' quantitative ability is 168.651 points when verbal ability is 0. So that with that, no, we now have the elements of our equation and we just plug it in here. That's y is equal to 168.651 plus 0.772x. Okay. And with that equation ready, we can now fill up this second to the last column, the predicted quantitative ability, or y predicted. So we just plug in the values to the formula. We know A from solving it. We know B from solving it. So now we just use the different values of X, no? Eric's score on verbal ability, Scott's, Henry's, Jane's, Kurt's, so on and so forth, no? So you should solve it like this. So y is equal to A, which is 168.651 plus 0.772 positive. X of Eric is 536. You'll end up with 582.443. All right. Do the same for the rest of the students and you will get these answers. All right. For a total of, oops, no, wrong. Oops. No, this is not the total. This is for Remy. I spoiled it. Anyway. So yeah. So speaking of Remy, let's go to his y predicted. No? We have the elements already anyway. So we just need to show that we're still using the same regression equation. And Remy's x score is 600. So let's just plug it in. And we will get 631.851, which is this one. Yeah. To interpret, this is how you write it. The regression analysis reveals that with a verbal ability score of 600, Remy's predicted quantitative ability score is likely to be likely, no? Kasi nga, we are dealing with Y predicted, no? So, we are not entirely sure if this will be their score. Pero based on the regression model, it is predicted that Remy will score 631.851 in the math exam. All right. With that, we can complete the rest of the expanded data table by subtracting actual Y to the predicted Y here. No? So for Eric, the error term is around negative 41.443, meaning the predicted Y value over-predicted, correct? It over-predicted Eric's score because we already know that he only scored 541, but the regression model is suggesting that Eric would score 582.443. Let's do the rest of the prediction errors. So once again, in Scott's case, the regression model over-predicted his score on quantitative ability. The same with Henry. Si Jean, on the other hand, the model under-predicted her score. No, she got 726, but the model only predicted that she will obtain 725.263. For Kurt, it's the same over prediction. Aurora over prediction. Kitty is over prediction and by far one of the largest over predictions, no, because she only scored 473, no. But with the knowledge of her verbal ability, the regression model predicted that she will get 525.315. For Anna Marie naman, as you can see, this is the largest under prediction ever because the regression model only knows that she got 530 in her verbal ability, so it severely underestimated her. No, saying that she will probably get 577.8 only, when in fact in real life she got 799 in quantitative ability. So next for Jubilee, it seems that her and Jean got the regression model got closest, no, had the most accurate, nearly accurate predictions for them. But for the rest, medyo over-predicted sila, except for Anna Marie. All right. Now we can proceed with getting the correlation coefficient now that the regression analysis is out of our way. No? So for R, so yun ulit, i-plug lang natin yung mga nakuhanan nating values from earlier. And we will get that the correlation between verbal ability and quantitative ability is around 0.717. So this is moderately high, no? Moderately strong. The F, of course, we have 10. No, so we're not including our additional student, right? We're only using the first 10 that were randomly sampled. So it should give us 8. Now the coefficient of determination is telling us that the variance that verbal ability, no, your independent variable can explain is 51.409%, which is okay. No, that's an okay percentage. No, in reality, it's really difficult. This is quite fortunate. We're quite fortunate enough that with just one independent variable, 51% plus is already explained by it. No, but in reality, that's why we do multiple regression, because one variable might not be enough to explain the phenomenon, to explain the criterion or your dependent variable. So um, regression analysis typically features more than one IV. No, so yeah. So going to the scatter plot, no, it should look something like this. The scatter plot is what you will get when you plot the scores of each student on X and Y. No? So ignore first the straight line because that is the regression line that I've been talking about for this presentation. So yung scatter plot is simply the dots. No? So what I expect from you is to label to name your graph properly. So in this case, the name of this graph is the correlation or the relationship between students' verbal ability and quantitative ability. I also need you to properly designate your X and Y. X will lie on the horizontal axis, while your Y scores will lie, or Y variable will lie on the vertical axis. So in this case, verbal ability will be here in the horizontal axis, and quantitative ability is here on the vertical axis. No, and I need you to label them properly as well. No, if you don't put these terms, no, the names of the variables you're trying to plot, the graph will be useless. It won't help anyone reading it. It will just confuse the reader as to what do these dots mean. No? Aside from that, notice yung measurements. Now, the problem kasi is dealing with such large quantities, no? Hundreds. Technically, we don't want this kind of graph kasi usually it should start at 0 and then yung intervals should follow, no? But when I plotted this using Excel, it gave a very imprecise and awkward depiction of the data. No? That's why I decided to cut down on the intervals and start at 450 instead, so that the pattern is clearer and more noticeable. But in practice, we really want to start at 0 and count from there. So we need to include 0 here at the start. No? And then we just plot the X and Y scores of each student. So as I said, I did that using Excel. So I can show you here how I did it. So first I opened Excel, made a column for X and made a column for Y. And then I highlighted everything and then clicked on this quick analysis function. I was looking for charts, and then I clicked on more charts, and I chose all charts and chose XY scatter and chose this second option. Ito, kasi this one, it separates X and Y and we don't like that. We want this. I said, okay. So yan. Ito yung sinasabi ko earlier that when your intervals start at 0, no, this is the more accurate one, but it gives us a very awkward depiction of the data. So what I did was, no, if it can't be here, because I don't like this, I clicked on this, went to format axis, and instead of my minimum being 0, I think I started with 450. No? Kasi I was checking quantitative ability and the lowest score was 473. So 453 until 850 because the highest score is 799. So that's what I did, 850 na lang. And then yung interval units is just 50. No? So there. Did I do anything else about this? Yeah. So there. Huh? And the same goes for verbal ability. So it's still awkward. So instead, my minimum became 450 and ended it up with 750. No? And then, assist na to. So there. So I think it's much clearer, right? And then the axis titles, I added them. Ito, I changed this to the relationship between, so we can correlation between students' verbal ability and quantitative ability. Quantitative ability. And then this is your Y, so this is quantitative. Quantitative ability. Meanwhile, this is verbal ability. There. Now, how did I draw the regression line? Let me figure that out. I think I added a chart element, which is the trend line. There you go. And I chose linear because we're dealing with a simple linear regression. No? And then I think I changed the format because this is not a line, these are dotted lines. So there, I did that. As I've said, no, your Excel has a correlation and regression analysis function. So I click this, I believe, and I can modify here yung linear. So I think I set the intercept at, what was the value of that? I set the intercept at its value, which is 168.65. I asked them to display the equation on the chart. Oops. Just so you can see. And so let me go back. No, I also asked to display the R-squared value on the chart. Now it's quite off. No, it's 5 point, as you can see here, 5.141. Pero I put here 5.5141 because nag-round na ako kaagad. So I'll just pattern that here. Pero it's actually 0.5135 if you don't round until the end. Pero if you go back to my previous file on the sample problem, I actually rounded. No? When I got the final answer for R squared, ang ginamit ko na for interpretation was a rounded answer. So I'll just do that here. So yeah, it also gave me not just the y-intercept, not just A, but also B. No, so yeah. Did I miss anything? Yeah, I think okay naman na. So yeah, so basically that's how I got my scatter plot and drew the regression line. Now for the problem set, you can do this. So it's much easier and more efficient. But if you want to draw using a graphing paper or using your notepad, no, in your iPad or your tablet, you can also do that. No, it'll be a little more laborious, but you can also do that. So there. Okay. So let me save that. And let's go back to the problem. So there. And the last thing to finish is the elements table. So the statistical analysis we are using is correlation using Pearson's R. So we're done with the regression, okay? We are simply finalizing our answers now with the results of our Pearson's R. Our research hypothesis could look something like this. The verbal ability of students is not related to their quantitative ability and vice versa. Alternative is it is related to their quantitative ability and vice versa. The statistical notation, 0.05 as level of significance. Now critical value, we will need DF, which is 8, and 0.05, which is your level of significance. So let's see the table. So that's 8, right? And 0.05 for two tails is 0.6139. So let's see if that's what I wrote. Yeah. So decision rule na lang. Pag mas mataas, if the Pearson's R we computed of 0.71 is greater than 0.6319, then we reject HO, which evidently it is. Yeah, so we reject HO. It is most likely that a significant, moderately strong positive relationship exists between students' verbal ability and quantitative ability. This means that the students' capability to express their ideas using words in a clear manner increases. There is also a tendency for them to do significantly well with solving numerical problems. As an explanatory variable, verbal ability can explain 51.409% of the variation in students' quantitative ability. Now you can also interpret the coefficient of non-determination. No, that's also an interesting value to have. That's simply 1 minus r squared. So there. That is our sample problem on simple linear regression. No? Yeah. So let me go back to my PowerPoint and wrap this all up. So here, no? So we answered this. We also knew about Remy's predicted quantitative ability score. So that's the end. It's not really the end, but for the presentation, it is the end. There's a lot to learn more about how to do a regression analysis, but for an undergraduate statistics course, learning about the basic thing on simple linear regression is sufficient enough, no, so that it'll inspire you to learn more about it in succeeding courses, and if you plan to pursue more advanced studies in statistics or social research. All right, so far, no, I'd like to end with this. For part 3 of the course, we took on inferential statistics and learned about these things. Now, I hope you still remember them. I know it went by so fast, no, but we were able to achieve a lot in such a short amount of time that we learn together, no, these concepts and theories that um, comprise inferential statistics. So we learned about probability, parameter estimation, hypothesis testing. But for part four, no, in the last few weeks, uh, we also learned about correlation and regression analysis. No, and earlier we differentiated between the two, but also pointed out how they are extensions of one another and how they are complementary. So, yun, I hope um, this short survey of basic statistical tools and techniques will help you with your future courses that are quantitative in nature. And I also hope that it'll inspire you perhaps to conduct quantitative studies for your other courses or for your thesis course. No, I believe I have provided you with the necessary tools, resources, and of course, the knowledge and skill set to um, help you, at least conceptualize and to help guide you in um, planning and implementing a quantitative type of study, or research. So, yeah, that's a wrap for Software 101. I guess my parting message for you is just like what I've been emphasizing, and uh, um, I should say that I really emphasize this quite a lot throughout our lessons in the sync in the video lectures. Now, I hope when you do statistics, when you encounter statistics, um, you understand what you are reading, you understand what you are consuming, that there's always some meaning and purpose to all these numbers, to all these values, to all these computations, no? That what differentiates you from other consumers or students of statistics should be the appreciation and the comprehension of the meaning behind the numbers, no? How it'll make us, how it'll help us make sense of social reality better, how statistics can be a tool that we can use to communicate not just between ourselves, not just between those who have a privilege to get an education and learn the language of statistics and the social sciences. No? But I hope it's also a way for us to reach people, no? Which essentially are the ones we are studying. No? So I hope I made it very clear to us. This shouldn't be a niche thing. This shouldn't be exclusive to us that had the privilege to get an education and learn about it. We should carry this with us and use this to help people, especially marginalized sectors in the population, no, to make sense of their lives, but in a better way, no, to help them, if not solve problems, help them be enlightened about some social problems that they are experiencing or encountering in their daily lives. So that is my hope, that you guys, that the class carry as they move along their academic, what do you call this? As they move forward in their academic ladder. So that's one. The second one is, because we are dealing with numbers, it's very easy for statistics to be misused and abused. No, it's very easy to be used as a conditioning tool, as a way to deceive people. So I hope we use what we know now about statistics to rectify that, to minimize that, or to completely eliminate that. No, because it's very prone to misuse and abuse. And I don't like to blame statistics entirely for that. It's people who are using statistics that do that. No, so I hope you will be the ones who have learned about it, who will try to avoid doing, who will not do it in the future. No, who will use statistics as something more positive, something more uplifting, and something more helpful to society. No, because if you look it up on the internet, statistics has been used to commit scientific fraud, not to deceive people, to sway or skew perceptions, not to um, favor others in certain social and political policies. So I hope we cut that um, malpractice altogether by being not just savvy but responsible students and consumers of statistics. So, with that said, thank you for bearing with me and to listening and watching all the presentations that I have prepared for the course. So, there. Thank you so much.